Hello everyone. Let's have a look over list data structures, which are the examples of non-primitive data structures. They are linear data structures in Python programming language. Lists are mutable because you can change the elements in a list after it's been created. They are dynamic because they can grow and shrink in size as needed, and elements are accessed by their position or index. By default they are started from the 0 index. Like you guys can see here that 22 is saved or at 0 index, 44 is saved at index 1, 11 is saved in index 2, up to so on. So it means that the indexing by default is starting from 0, from accessing the elements from left to right. If you would like to see the data elements from right to left, then you can go for indexing or position like from -1 to -7, and you guys can see that they are sequentially progressing. So let's declare a list in Python, and let's see how these data values can be printed. And lists are versatile because they can hold mixed data type. They can save heterogeneous data types of any primitive data types, such as a string, integer, boolean values. So let's have a look over them using Python programming language. So I hope the font size is good for you guys. So let's have a look over these examples. So let's first declare the list of integers, and we would like to declare list of integers such as I have shared here by the help of example. We have this example, and here we can type some of the integer data values over here, and you guys can see here that I have assigned these different data integer values using square brackets. Assignment operator equal to is an assignment operator, and integer underscore list is the name of the list. You can name name your list any name. Okay, so even you can use your own name, but names should be always sensible and descriptive. So when I will run this cell, you guys can see this cell is successfully run. And now if I would like to see the elements of the list, I will type the name of the list, and when I run this cell, it will print for me the data elements inside this list, integer underscore list. Let's suppose I would like to print the index 0. At index 0, as I have shared, that 22 is saved at index 0, and I have shared here index 0. Now when I will run this cell, you guys can see that 22 has printed. Let's suppose I would like to access the elements from right to left, integer underscore list, and now here I will type -1, and when I will run this cell, you guys can see 77 has printed. Definitely we can traverse all the data elements by using for loop, which I will share gradually with you guys. Now let's try some more built-in functions to understand more about the nature of the list. Let's suppose there is a built-in function, type function, and inside the parenthesis I will type the name of the list, integer underscore list. When I will run this cell, you guys can see that the data type which is printed here is the list data type. Let me make a string list, string underscore list, and here I will be declaring a list of some characters. Let's say G, H, and maybe let's have a K. Okay, so when I will print this, it has printed. And now string underscore list, let's suppose I access 0 index, it will print G for me because G is saved at 0 index. Let's suppose I would like to see the type of this string list. I print the name inside the type function, and when I will run this cell, then data type of this list is printed, which is list here. Let's explore more. Let's suppose I would like to see how many data elements are in these lists, in these created lists. Let's suppose I would like to see how many data elements are inside the integer underscore list. So for this reason I am using here this built-in function length function, and when I will run this function, you guys can see 7 is printed here. Now let's suppose I would like to see the length of a string underscore list, and when I will run this cell it will print 3 for us. It means that the length function is sharing or returning for us how many data elements or data values are in these sequences. Let's explore more. Let's suppose I would like to add a new data element in integer underscore list, because I shared with you that we can extend and add more data values in the created list. So there is a built-in function named as append function, and let's suppose using append function I would like to add a new value in this list, and the new element is 99. Inside these parentheses I have shared 99. When I will print this, it will be printed, nothing is in a printout. So when I will again type the name of the list and run this cell, you guys can see that 99 has added in integer underscore list. Let's suppose I wanted to extend this list by new values, and now here there is another function known as extend function. Extend function, inside this extend function I will use the braces, and here I will be adding some more integer values, and when I will run this function, this cell, it is successfully executed. When I will run integer underscore list, you guys can see 4 5 6 is extended in the original list, which was integer underscore list. Now let's suppose I would like to remove some data elements. So there is a built-in function named as remove, and inside remove function I can print, I can type the data value. Let's run it empty with no value. It will raise an error that dot remove takes exactly one argument and 0 has given. So we need to give at least one value, that which value we would like to remove. Let's suppose I would like to remove 6. When I will run this function and again print the integer underscore list, then you guys can see 6 has removed from the end of the list. Let's suppose I would like to do integer underscore list dot remove function, and I would like to remove 22 data element. Now when I run this cell, when I run with the name of this list, you guys can see there is no more 22 in the list. There is another function which is used to remove data elements, and that function is dot pop function, and dot pop function needs no argument inside these parentheses, and when I will run this function it will run successfully and it will remove the last data element in the list. So when I will print integer underscore list, so you guys can see that 5 is no more at the last of the integer underscore list. Now let's have a look over sort function, because sorting is the very important operation of the data on the data structure. So we would like to sort this list. We want to arrange this list in some kind of order, ascending or descending. When I will run this cell and again run the check the integer underscore list, you guys can see the list is sorted. If you would like to see the definition of sort function, and when you will take your cursor over it, you guys can see that Colab will show you the definition of the function. So by default reverse equal to false. So it means that the sort the list in ascending order and return none. So here you guys can see that if I would like to change the order into reverse order, then I will need to make reverse equal to true. So these are the functions which we can use. These are the built-in function we can use over lists. So there is one more function which is very interesting. Let's check integer. If I would like to see that how many times some data element has occurred in the list, let's suppose I would like to see how many times 44 has occurred in this list. When I will run this cell, you guys can see sorry, a list count function. This is a count function which will count that how many times 44 has occurred in this list. When I will run this function, you guys can see it is showing that 44 has occurred only one time. So let's add another. Let's now insert a new data element in integer underscore list by the help of dot insert function, which is again a built-in function. We need to give two arguments for this function. First of all, on which index I would like to add this element. I would like to add at, let's suppose, at third index, and the data element is again 44. When I will run this cell, it will be run successfully, and then when I print this this list of integers, you guys can see at the third location I have 44. Now I would like to see that how many times 44 has occurred. So I can call for count function and check for 44, and when I will run this function, you guys can see that 2 times 44 has occurred in this list. Let's create a hetero list over here which can save heterogeneous data types in this list. Let's suppose, as I have shared in my example, that we would like to store students ID, name, and everything, different details of the student. So let's suppose a student ID is 2001234, and I would like to share his age, and then in the next one I would like to share his full name. Let's say full name, and let's say I would like to share that the gender is, let's say, true for male category, and I would like to also add some address. Address, let's say street, house number, okay, and let's have a town, okay. So such details if we will add for as an address. And last but not least, another list of his courses. Let's suppose he's taking maths, he's taking English, and he is also taking Python programming language. Okay, so when I will run this cell, you guys can see that Colab has executed successfully this list having heterogeneous data types. So we have integer values, we have strings, we have boolean values, we have a list of lists which is successfully created. Now I would like to see that what is at the index, let's so say 0 index. When I will run this, you guys can see student ID has printed. Same will go if I would like to see that what is at the fourth index. So at fourth index I have the address of the student. So let's see what is at the -1 index. So at -1 index, you guys can see I have listed some list of his courses he is taking. And if I would like to see this list, let's suppose I would like to see this English. So then for hetero underscore list, I would like to see at fifth index, I would like to print only English, because the indexing of English is 1 0 1 2. So in when I will print this, run this, execute this cell, you guys can see English has executed. So that's all for the introduction of the lists using Python programming language. We will explore more Python using these data structures, saving different data types for data manipulation. Thank you so much.